Where am I? Here we are. Okay.
I'm going to put this lecture link in the announcements.
Hi everyone. So you may have noticed that we've changed computers that we're streaming from. We've changed a few things. We're trying to get things set up as soon as possible. So please just stick with us in this call. We'll let you know as soon as we're ready to go, and we'll have Sasha back here walking through today's lecture. So thank you very much for all of your patience. We'll be back with you as soon as possible. Hi everyone, I'm hoping that I'm audible. We're just getting things set back up with a slightly different setup, which we're hoping will be a little bit better. So please hang tight, we'll get started as soon as we can, and we'll have Sasha back here in a moment.
Hi, everyone. Can you please let me know if you can hear me on the live stream? We're just checking that everything is going okay before we start lecturing. Can you please let me know if you can hear me on the live stream? We're just checking. All right, everyone, here we go. I wish I was in a flight taking off right now. Somewhere nice. I hope somewhere with nice sun, cocktails by the pool. Why not?
Hey everyone, just so people know, we've noted that there is in fact an echo. We're just trying to fix that up as soon as possible. Alrighty, we found the source of the echo. That was actually my fault. I'm just checking that the echo's gone now. Sounds like it. All right, so Sasha, we'll go back over to you.
All right, hopefully now no more echo. A really exciting start to week 4 lecture. I'm so sorry about that. I thought I was doing great. You know, I spent like a few hours at Bunnings on the weekend finding cords and cables because that's the only place where you can go into a shop. And everything was like hard plugged in. I thought today was going to be the day that the internet for me would just be like supreme, but unfortunately it went completely the other way and I crashed everything. So that was great. That was really nice. But that's called, that's called some super breaking. Thanks all for sticking with us, and fantastic that you were able to rejoin us on this new stream. Because we're going to have a little chat about the assignment. We're going to revisit. Bunnings is open. Yes, you can go in and you can get some serious moral fatigue from people not wearing masks. So absolutely, but no sausage sizzle. So, I mean, it's not the same. Okay, so and then we'll revisit arrays because we kind of went hard and went strong on arrays last week. And we're going to talk about 2-dimensional arrays as well. So I'm sorry again, but hopefully we'll be able to get through most of the things that I had planned for today. Okay. So we have for you a bit of a treat. Is it a treat? I don't know. Maybe, I think so, but is my opinion biased? Maybe it is. But basically assignment 1 is out. So you guys can, just like calm down. I know you've been super excited for the last 3 weeks waiting for this assignment. It is out. So if you go on our homepage, then you will see that there is a link for assignment 1. And if we go through on the link, you will be taken straight to the lovely assignment. And I might let Alvin talk a little bit about the context of the assignment because he is the mastermind behind CSC Valley. So if you don't like it, you know who to blame.
Hi, everyone. So just to give everyone a bit of an overview. So essentially, like the name suggests, it is similar to the popular game that ends with a valley as well. And what we're trying to make you do here is to implement the functionalities that would occur in the game. So an example of that would be, say, to move around the farm and possibly to farm in a specific way, or to water in a specific way as well. And towards the end, you can then harvest and in a specific way as well. I'm trying to not give you too many spoilers here, but yeah, I think it starts from, so you don't have to implement all the functionalities all at once, but the more functionalities you make, then the more moves that the farmer could do. So that's sort of like a brief overview, I suppose. Sasha, do you want to continue?
Yep. Okay. So in this wonderful assignment, which is quite fun to do, we have a beautiful world of a person in a two-dimensional array, and they're trapped by that two-dimensional array. No, they're not. The farm is envisaged as a two-dimensional array, and we'll talk more about what it means to have a two-dimensional array today. And the assignment is basically going to be you prancing about in this two-dimensional array, doing a whole bunch of things like planting and harvesting seeds and printing things out. And there are 4 stages to the assignment. So if you have a look, we've got the 4 stages here for you as tabs. Each stage is also classified with its difficulty, so you are able to kind of see, what stage, like how much effort you might need to put into each stage as well, and how much effort each stage gives you. And each stage is worth a different amount of marks. And basically the first 2 stages if you complete the first 2 stages, down the bottom of the assignment, we have the mark components for it. So it's 50% for performance if you have the completely working stages 1 and stages 2. And don't forget, that's for the performance mark. So 20% of this assignment is based on style and 80% is based on performance. So don't forget, style your code nicely. Make sure you, do neat coding, good indentation, good variable names, use of functions and so on and so forth. So make sure that you actually set out your code very nicely. Now, this also brings me to the next point in that help sessions are going to open this week. So I strongly encourage you to start the assignment early. And the reason for that is because I think you need to read over it completely once without sort of just rushing to your computer to do any coding. Read over it, try and understand exactly what it's asking you to do. Then go back and read over it again. So read over, say, stage 1, and maybe draw a picture, draw a diagram of what, how you envisage solving it. And then after that, you can maybe try a little bit of code. But, once you start drawing your diagram to try and solve it, then what happens is that you might have some questions as well. So those questions can go either on the forum, and we will have a special assignment 1 place to place your questions. But also what it means is that you can go to a help session if you need help, and if you want that sort of a bit of a personal, if you have more than one question, or perhaps you have questions that are specifically related to your code or whatever else, you want to go to the help session. There's something you really don't understand. So help sessions start this week. The first one is Friday, 4 till 6 p.m. And it is available on Blackboard Collaborate. So you can log into Blackboard Collaborate, and you will be able to find the link for this help session. So please, if you have any problems at all, start early, because then you can attend the help sessions. The help sessions fill up quite a lot when the assignment is due, right before the assignment is due. So that's going to really, going to add to things, to the pressure as well, if you can't be seen, within a certain time frame in the help session. So everything is in the course outline. You have until the 25th of October to do this assignment. It should be enough time. Help sessions are not recorded because help sessions are a place where you can actually go in, show your code to someone, to a tutor, and they can actually, have a look if they need to help you with something. It's the assignments. I know it can feel very overwhelming because it looks very long, but it's the fact that the assignment is broken down so much. We've tried to really help you to make it a very, very sort of step-by-step spec as well. So we've almost broken down the problem for you into components, and you have to go and solve each of the components. We also don't expect for you to start from scratch, okay? We are giving you some starter code to start with, and the starter code is able to do some things. The starter code also has some of the structures that you need to get started, okay? So this is why I'm saying, please read over the assignment first, because you need to understand what's already given to you and what you might need to do. So it's, these types of coding problems take time. I can't take away from that, but you can help yourself by starting early, because then you're not pressured to spend one whole day, 20 hours in a row without sleeping and whatever else trying to finish it. You can spend a few hours, at a time or anything like that. So you can really break it up for yourself as well, so you don't go crazy. And there is a lot of places where you can get help. You can also get help, perhaps in your labs, you can even ask questions, and in your tutorials. In the next few weeks in the tutorials, we will be covering a lot of the information as well that will be helpful for the assignment. So we're not just kind of giving you the assignment and leaving you to languish in it. There is a lot of places where you can get help, okay? And if you note the different stages of difficulty, we don't expect everyone to do all 4 stages, okay? And please note that you can get, like 90% of the performance marks without even doing stage 4, okay? So stage 4 is the hardest stage, exactly like sort of similarity ratings as you have had in the labs so far. So stage 4 is the much harder stage. But a lot of the marks are here in stage 1 and stage 2, okay? And then stage 3, please try and attempt it if you can. And, even doing that stage 3 partly, because there's a few parts to it, you'll be able to do, you'll be able to do quite well in the assignment overall. So please don't be overwhelmed if you can be. Ask lots of questions, okay? If you feel that any part of it overwhelms you or you don't quite understand it, post on the forum and we can explain it to you better. We can break it down for you better. So you really are able to, get help in a lot of ways, and we're able to kind of walk you through it as well in a lot of ways. To get full marks, if you want to get 100% in the assignment, you have to do all 4 stages, and using fantastic style as well. So using that style guide that we have provided you with and all the different style that we've talked about. So if you have any questions, just pop them into the chat. Tom, do you have anything more to add to the assignment?
So there were a few things I wanted to go through quickly, if that's all right with you.
Sure.
The first thing I wanted to emphasize was that, as you said, Sasha, we don't expect everyone to do the whole assignment. And there's a bit of a mentality shift that sometimes happens, especially if you've come straight out of high school, because getting 100% is not necessarily everyone's goal in COMP1511, and that's okay. There'll be people who only get up to stage 2 or only get up to stage 3, and that's perfectly fine. 100% is basically saying you have like pretty close to mastered all the things that we want you to understand, and not everybody needs to get there. You can get 80% in this assignment or 70% in this assignment and still be really set up to do well out in the rest of the world, still be really set up to do well in assignment 2. So don't feel like, oh my goodness, I didn't get stage 4, everything's going wrong. That's absolutely not the case. It's totally fine not to get 100% in this assignment. The second thing which I'd say is there are free marks in this assignment. 20% of this assignment is free marks, and what I mean by that is style. If you can run 1511 style, you look through your code and you say, yes, I can understand what I've said, you can get a lot of marks. You can go straight from like getting a credit to a distinction basically on the basis of your style. So that's a really important place to spend some time thinking about, have I written my code well? The third thing I would say as well is there is a live stream, and Sasha might want to scroll up to the live stream link on Thursday at 6:30 p.m. That will have Alvin and I going through the assignment step by step. We'll talk through how you set things up. We'll talk through how you like sort of what each stage is and draw out diagrams and that sort of thing. I'm also expecting that after the live stream, that link will be available and we'll have like timestamps so you can jump to different parts of it. So that's going to be a really useful resource. So either go and look at there directly, or if you can't attend live, you're more than welcome to watch the recording later. The last thing I would say as well is please get started early. I know that Sasha said this and everybody in your tutes is also going to say it. Get started as soon as you can. What I would actually suggest is if you follow the getting set up instructions before Sunday. And I think we may even reach out to people who haven't followed those instructions by Sunday, just to make sure that everybody knows, hey, let's get started early. The earlier that you get things ready, the more time you've got to go to help sessions, to get help from your tutors, those kinds of things. So please, please, please get started early. I think that's all of my points. Shrey, did you want to add something as well?
Yeah, I think you've covered it pretty well, Tom. I just want to emphasize that if you go your entire university career getting only 75s, the university actually gives you a big award, saying you've done a really great job. So as Tom said, there is actually a very large mentality shift when it comes to marks at university. And I'm not going to talk too much about it, but set your expectations.
Well, just, yeah, okay. I don't know. My dad always used to say, anything more than a pass, you've worked too hard, which is, very, very low bar.
Please get degrees.
Yeah, well, I mean, yeah, he always said, you get your piece of paper, but you learn on the job, which is very true as well. But I really would like also to say, try and have fun doing this assignment, try and actually enjoy it because, I know it's very hard. I know you've got a lot of things due, but try and enjoy it at least a little bit because it makes things go so much better as well. And if you engage with it and you enjoy it a little bit more, then perhaps it's a little bit better as well for you guys. So good luck. Know that you're not alone. Please, if you have any questions at all, just ask them. There's so many avenues where you can ask your questions. So please, 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 don't suffer in silence kind of thing. If you don't understand anything at all, just ask on the forums or ask, during the help sessions. And we're going to be having more help sessions as well next week. So there's going to be more than just one. So you'll be able to get some help as needed. And in that assignment live stream, which is on Thursday at 6:30 p.m., we're going to be really going through in a lot more detail of the assignment. And we're going to help you, get to the stage where you're ready to get started as well and explain things a little bit more. So I think it's a really worthwhile thing to join. If you join in for an hour, and you will be able to be, you'll be able to kind of have a lot happening for you in terms of actually pushing you to get started as well, which is nice always. Okay, so let's go on with this lecture. So someone's asking, is this assignment going to be like the box or the spiral? I think actually, I almost think sometimes the assignment is easier, a lot easier, because, and when it's marked the 1 star, it is a lot easier, but also the assignment has really set out the different stages. It's segmented the problem for you, which makes it a lot easier as well, because it's already broken it down for you. You don't have to, you don't have to think out of the box in a spiral. I just had to insert that in, but you don't have to, it's literally the solution is kind of also there for you. The only place, in stage 3, it starts to get a little bit harder. Stage 4, obviously you have to do a lot more thinking, but stage 1 and stage 2, the specification is very kind of like letter by letter. You kind of have to do exactly what it says. So you really need to, I always think draw a diagram, especially with arrays, draw a diagram, and it will really help you to see and visualize what is actually happening. And especially in that 2-dimensional array, draw a diagram, and which we'll be doing today, hopefully in a very short time. Okay, let's have a look. Oh, Shrey's admitting that he's never done the spiral or decimal spiral. I have to admit, decimal spiral gives me nightmares. So, and yes, Lisa has brought up a good point. We want you to submit as you go, submit as many times as you want, submit, because when you submit, each time you submit, what it does is it makes a backup. So you don't have to worry if you lose everything. There's going to be a backup of that. Also, it allows us to see your code if you have any questions at all. Only your last submission will count towards marking. So submit often and submit early and submit as often as you want. Submit every hour, submit every 10 minutes if you want. It's great to keep submitting. Okay, let's continue. Okay. Let me just switch what I'm sharing with you.
While you're doing that, can I add something, please, Sasha?
Sure.
On the difficulty of assignments, it's worth noting we design assignments to kind of have a difficulty ramp. So the first bit's going to be hopefully stuff that you've really done before that won't feel new. The thing that assignments are testing is not only like the content itself, but also it's partially about having more code in one place, right? So if you've got a big program, then you've got to deal with, how do we structure our code nicely so that it's readable? How do I reuse little pieces of code in multiple places so it's really nice and functional? So one of the things that we definitely emphasize with the assignments in particular is dealing with multiple things going on at once. Like each individual exercise shouldn't feel bigger than a lab exercise. Each individual part of a stage won't feel bigger than a small lab exercise. But putting them together, that's sort of part of what we're testing as well. And of course, in industry, what you're doing is you're never working on one lab exercise in isolation. It's always code that's got other code. So this is actually one of the best ways of practicing for when you move on to future courses or when you move into the industry as well.
All right. Okay. So thank you for that, Tom. Just whatever you do, don't please try not to get stressed. Just attempt it and do your best as well. Oh, you just got to see Tom's face in the middle of the screen share. Okay, so lecture code for today is located. Okay, now it's just having a field day here. Lecture code for today is located in the lovely link that we kind of always use. So the week 4 section is where the lecture code from today will be at. Okay, let's do a little bit of okay, we've just talked about assignment, so I'll skip over these 2 slides. We're going to try and wrap up at 12 o'clock, and what I'll try and do is I'll try and if I go a little bit longer, the lecture will be recorded, okay? And you'll be able to watch through the recording. I'm really sorry about the situation that we have found ourselves in today. Okay, so let's talk a little bit of a tangent to talk about C libraries, just because you will start to borrow a few more things from other libraries as well as you go on. So far we've only used our stdio, so the standard input-output library, which gives us access to our printf and our scanf, which we have used quite a lot. But we're heading towards territory where we're going to be using a few of the other libraries. I've provided you a link here, and this link kind of has a summary of all the libraries, and it has a summary of what is in each library, so what functions you can borrow. And so I think it's a good place to kind of add that basically what you're doing is you're borrowing some functions that have been written for you already. So it's like going to the library, borrowing some books, and then you return them. Well, it's kind of the same. You're borrowing some functions, and then you're going to, when you're done with them, you're done with them. But what it means is you're not rewriting something that already works and something that there's no purpose to rewrite as well because it's already there. So some other libraries that we're going to see are going to be standard lib.h, math.h. A few of you have used the math.h to get certain mathematical equations like absolute value and the value of pi, which are hard-coded in. And we're going to use a few more. There's going to be a few more libraries that we are going to get kind of familiar with. Or not even familiar, just a few functions. We're going to learn about them just to give you practice in borrowing all those different things. And one thing I want you to notice, just to keep in the back of your mind, is that whenever you borrow a library, you might have noticed that they finish in a .h. So it's a .h file. That's called a header file. And there is going to be significance for that in a few weeks. But I just want you to have that little tidbit in the back of your mind so that you remember that anytime that you include a standard library, you will usually be including a header file. So you'll do a hash include, and then whatever the library name is, and then .h. Yep. Okay. So let's continue. Okay. I wanted to do a quick little recap of arrays as well, because I think that arrays are pretty important. It's a very basic data structure that we need, and that is used quite a lot in computer science. So it's a pretty important one to understand. But basically an array is a collection of data all of the same type. So you can only, if you're storing ints, then every single element of that array is going to be an int. If you're storing chars, which we'll talk more about next week, and that's a special type of array, then every single element is going to be a char. If you're storing doubles, then every single one of those elements has to be a double. So when you have an array, every single thing has to be exactly the same in that array, and you might have a big collection of the same thing. So, you buy a box of chocolates, every single one is a chocolate, kind of like that. It's not like you're going to have, well, you might have a box of lollies and chocolates, but the good ones, just chocolates. Okay, an array is declared by using a type. So you say what type of an array it is. So if it's got ints in it, then you'll say that it's an int. You'll give your array name a name, and then you will give it a size as well. So it's pretty important to know what the size of the array is as well, because when you declare your array, so when you tell C that you're going to be using an array of a certain type, what it does is it allocates the memory spacing for that array based on the size of the array. So if there's 10 ints and each int is 4 bytes, then it's going to straight away tell me that it needs 40 bytes to store that array. You can easily access individual elements of an array by using an index, and we're about to do some code to remember all of this. And indexing always starts at 0, moves through until size -1. So because the size of the array, we start counting at 1. Don't forget, indexing starts at 0, which is why there is no index at size. It's only size -1. And arrays go hand in hand. They are best friends with loops because that's the way to traverse through the array to find whatever it is that you need to find. So you'll be doing lots of while loops now. Okay. So last week we looked at an array which kind of, talked about how many parcels there were in a week. So just to remind you, the indexing is down here. It starts at 0. If the size of this array is 7, then the index is going to go from 0 to 6. Each element of this array is going to be an int. The name of the array is called parcel week. And to declare it, I say int parcel week, and then in square brackets, I give the size of the array. If I use the curly brackets, that means I'm about to initialize my array. So I'm about to say what the initial values will be in that array. If I have just a curly bracket and a 0, that means I've initialized it all to be 0. Okay, so that's, someone's asked that so when you initialize an array as 0 inside curly brackets, it means every single one of these elements here is going to be equal to 0. Now I've initialized it with 1, 2, 3, 4, 5, 6, 7, which means that these are the numbers that are going to go into the different elements respectively as well. Okay, so let's try and do an array problem, and then we can have a look at some of these different questions that people are asking as well, which are really quite clever questions. So someone said, can you initialize with 1 instead of 0? So if you initialize with 1 and the array size is 7, it's going to do something a little bit different. So 0 is the only one that it's going to fill out all zeros, okay? If you do 1, it's going to do something different. And you cannot initialize it with just empty brackets, because empty brackets don't tell it what initial value to give it. You need to give it initial values, which is what initializing is. So that's why you can't just have empty curly brackets. Okay, let me switch screens to the gedit. Give me a second. Okay, so we're on the gedit now, and I wanted to practice doing our one-dimensional arrays, and I want to do it by looking at a problem that will basically allow the user to input 10 numbers, and what it will do then is it's going to find the largest number in that array. So let's have a look. Okay, so the first thing I always like to do with arrays is I like to draw them. So our problem is a user is asked to enter 10 numbers. We will then go through these numbers and find the highest number and output what the highest number is to the user. Okay, what I'm going to do is I'm going to just copy that to a blank document here, because I'm going to draw up the array. Okay, so basically what we're doing is I'm going to have an array. If I'm asked to enter 10 numbers, that means the array is going to have 10 elements. And if it has 10 elements, then it's going to have 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my indexing, remember, starts at 0. So the indexes are going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the index from 0 to 9. So I'm going to ask the user to enter in 10 numbers. So that means the user is going to initialize this array for me, because I'm going to use scanf to take in what they want the numbers to be. And then I'm going to search for whatever the highest number is. So if I have, for example, if the user has put in 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, I want to find the highest number. And this is a pretty common problem in, shouldn't have done it as an array of 10, it's too many things. But anyway, this is a pretty common problem in computer engineering, finding a biggest element in something. So what are some different ways that you guys reckon you would do it to find the highest number in this array? What do you reckon? How would you approach it? What do you reckon? Yeah, so if statements. Yeah, definitely we're going to have some if statements. That sounds like a good one. What am I going to compare? How will I do the comparison? Loop through, storing the highest number as you go. Yep, someone's got the perfect solution for us. Yeah, a loop that checks last highest number found compared to current. Fantastic. So I'm going to have some sort of highest number. And what should I make that highest number that I'll be comparing each element to? Well done, guys. That's really good. So I'll have a highest number. What do you think I should make it in this case? When I first enter my loop, what do you reckon it will be? What do you reckon I'll initialize this variable to that I'll start comparing with on the very first run of the loop? Okay, so people reckon 0. Okay, 0 is a number that I can still put in as one of my, in this case, it will work for sure, but 0 will be a number that I can maybe have in here as well if the user decided to scan in a 0. And that means if I can compare 0 and a 0, it's going to give me a wrong comparison. So I want to, yeah, so someone's saying minus a lot of 9s. Say something like that, but I mean, really, I can just do -1 because I know that my numbers, well, I haven't constrained them, but in the problem, it should really only just be positive numbers. So what we then want is if I set it to -1 on the first go, I know that it's definitely going to be smaller than the first element of the array, which means that I will be able to do a good comparison with the first element of the array as well. So let's have a look at how we can do it in code as well. Okay, so first of all, we know there's some things that we can do very easily. So first of all, let's take numbers in from the user. And we know how to do that. We do that all the time. We're going to use our lovely scanf. And so Catherine's asked a great question. What if elements of an array are just negative numbers? So absolutely. So the question, then you would not be able to set it to -1. That will change the whole question. And it depends what the question is asking. And I should have been more specific. If this says 10 positive numbers, then putting that highest number as -1 on the first go is the way to go. Otherwise, you would see what that question is asking you and how it's constraining it as well. So let's go. First of all, I'm going to need an array to store the numbers in. So I'm going to call my array numbers. It's going to be of type int because it's storing integers in it. And then I'm going to make it an array, square brackets, and I know that I need to store 10 numbers. So it's going to be have the value, it's going to have the size of 10. I'm going to initialize it to 0 because why not? So what I'll do is I'll open a curly bracket, I'll put a 0 in and close the curly bracket. And what that means it does is, what it actually does if you do that is it says 0, 0, 0, 0, 0. How many zeros is that? 3, 4, 5, 6, 7, 8, 9, 10. So that's what it actually does when I put in 1 0 like that. It initializes every single element to 0. Okay, so now that I have a lovely array to scan the numbers into, I want to have a while loop that will allow me to scan the numbers in. So I'm going to have my lovely index here going. So int I is equal to 0. And then I'm going to have a while loop to do the scanning. So whilst I is less than 10, which is the size of my array. Why is there a comma? That is a very good question because I was already thinking of how to do this lovely curly bracket here. So thank you for picking that up. Okay, and don't forget to increment as well. Okay, so what we have then is we'll ask the user what they want the number to be. And then we will scan the number that they want into. So we'll scan the %D of the number, remember the ampersand, and then we're going to scan it into the array. So we do it exactly the same way as we scan into a normal variable, except this time we give an index in which to scan to. So remember, you can't just scan things into an array as a whole. You have to scan it into a particular index of the array because you're scanning in one int. And each element is one int. The whole array is not one int. So what I'm doing is I'm providing it this variable index in here as well. So in that case, I'm going to scan it in and I'm going to scan the number and place it into my index of that array. Okay, and then I want to be able to do what? I want to be able to find the highest number. Okay, I think it's a good candidate to be a function, finding a highest number, because that sort of, it just lends itself to a function. So I want to be able to find the highest number. And then I'm going to output that highest number. So I can say the highest number is %D. I'm going to do a new line. Okay. Now, if I have a function, remember that a function will return something to me. And so what I can do is straight away, I can call the function inside my printf statement with an array name, okay? I don't have to, I can call it outside. So what I can do is I can say, okay, I'm going to have a variable called highest number. And on that variable is I'm going to call a function called, I don't know, highest number. That's not a good name to do because I've just named variable. So let's say the function name is called highest, and I'm going to give it my array. And so when you pass an array to a function, you just state the name of the array only in the round brackets. And then the name of the function, let's say, is highest. And then here I can do, okay, I've put the return of this function. So whatever this function will return to me, I've put it into this variable. So I can have the variable name in here. So it's exactly the same as doing it both ways. You can just save yourself some time if you do it the other way. But let's go with this to have it as a bit of a... So let's try and write this function now here that finds the actual highest number. Okay, so function finds the highest number in an array. What is going to be the input of this function? And you don't have to record these when you're doing your comments for style in the assignment. You don't have to write what the input and output is. That should be well obvious from the way you actually style your function. Yeah, Lisa, I will absolutely do it in a second. I will absolutely do the alternative way. So what will be my input and output in this case? So the input, I'm going to give it the, no, not the output, sorry. You cannot output an array, but you can input an array. Yep, so input is numbers. So I'm going to give it this array to traverse through to find the highest number. And what's going to be the output of this function? What will I return? Yep, output is int. So I'm returning an integer and I'm outputting an integer and I'm inputting the array into it. So first one, int, because I'm returning an int and the name, I don't know, highest. And then I want to do my input. So my input into it was an array. It was int numbers 10, okay? So remember when you write the function, when you write the top line of the function, when you're actually defining what the function is, then you want to actually say what the array is. So the array is of type int, and it is called numbers, and there are 10 things in there. I'm just going to pass that in. And it's not necessarily that you have to do this all the time, but we'll just do it like that so that it kind of remains step by step to start with. And then we'll start to do shorthands to eliminate some of these things. Okay, so I guess we said we have this lovely variable called highest number, and we're going to set it to -1 to start with. And what we're going to do then is we're going to have a loop, and we're going to go through the loop, and each time we're going to compare each of the elements to the highest number, and then set the highest number based on what the result of that comparison is. So again, I'm going to have an index that I keep track of, with which I will traverse my array. And then I have my while loop. So again, I need to go through the whole array. So whilst I is less than 10, because there's 10 elements in the array, and I'm going to increment the loop as well. Okay, and then my comparison. So what I'm comparing is, and we've said we're going to use an if statement to compare. So in this case, the if is going to be, I'm going to compare the element of the array that I'm at. And so we're going to have, and I've called it something else completely. So if numbers at index I is greater than this highest number that I have, then I want to set my highest number to be that element. Yeah? Okay. Then in that case, my highest number is now going to be whatever was at that index. So whatever is in that array at index I. And what that allows me to do is it allows me to constantly compare it. Okay, and then what am I returning? I'm going to return that highest number. So I'm going to return whatever the int is that stores that highest number in there. Yep. All right, so if we try to compile it, okay, I've got this lovely implicit warning, implicit declaration of function. Yep, well done, Zach. So I've forgotten to prototype the function. So I need to tell C that this function is going to happen for me, which I do before my main. So remember that I always have my I always have the definitions, well, the prototypes of my functions that I use before the main, so that C knows that they're coming. So I'm not just calling a random function. It doesn't think I've gone crazy and I think something's there that's not. Okay, and now here, what have I got as well? Use of undeclared identifier, highest number. So that's called bad spelling over there from what I can see. So I'm returning highest number with a spelling mistake, and that's not what my variable name is called. So let's try it again. So this will work if the array is in any order. And the reason for that is because it only changes the value of highest number if the element of the array at a particular index is higher than that highest number. So the highest number is only storing the highest number. Okay, let's compile it again. This time, no spelling mistakes, no forgotten prototypes. So let's run it now. And I'll do a whole bunch of 6, 7, 8, 9. The highest number is 10, okay? So what if we now run it and we do them in the opposite order? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The highest number is still 10. And if I do it in the middle, it's still 10. So it doesn't matter where my highest number is actually located because it's going to still keep the highest number in, it's comparing it, the highest number, to the element of the array, and it's storing it only, it's changing the variable name highest number only if the number is higher than what was already in there. Okay, so what we have is my function name is highest. And here what I've done, there's two ways to do it. So this is the long way to do it. Here I've got another variable where I'm calling this function and I'm returning this highest number, okay? Or what I can do is I can actually call the function inside my printf statement. Because that function returns an integer, it returns an int, and here in my printf statement, I'm asking for an int as my format specifier. I can actually call the function straight away from here, exactly the same way that I would call it from anywhere else, and it will do exactly the same thing. What it means is that I don't need this extra variable here. I can just call the function straight away because it returns an int, okay? So that's like the shorthand way of doing it. So if I run it, you'll see it makes no difference at all. I didn't mean to do that. Let me compile it just so that you can see that it makes no difference to where that's located. And if I run it, again, it makes no difference. The whole thing is exactly the same, okay? Oh, what if you entered 2? Someone has a great point. If I entered 2 10s, absolutely it would, well, it wouldn't quite break it, but it would just save the other 10 as, so it would save the subsequent 10 as the highest number as well. So for example, if I run it and I have 2 10s, what if I have all 1s? the highest number is actually still 1. So it wouldn't make a difference in this case. But that's a great way of thinking of how you can maybe break it, and thinking as well how you can make your code better. So thinking about all of those different places where a user might input something that you don't expect as well. Okay, so that's quite a simple use of an array to find the highest number in the array. Okay, we might have a 2-minute break right now, just to give you a little bit of a break, and then we can continue after that. All right, everyone, we're back. Hope you had a good little break. Okay, let's continue this wonderful, exciting encounter because we're about to enter the land of two-dimensional arrays. So let me swap my screen over so that I can go to, I should have done that earlier because let me swap my screen out back to the lecture slides. Yeah, my whole everything is just very slow today. It's all happening. Yeah, you get Shrey in there. Sorry, that's why I was kind of laughing on there as well, because I could just see Shrey. Oh, goodness, it's now sharing the wrong screen. This is not happening for me today. Okay, so what happens when we can have an array of anything, right? And it keeps cutting out. Why does it keep cutting out? It doesn't love me. So we can have an array of anything. So far, we've seen an array of ints. I haven't really done an array of anything else. Actually, I did an array of structs just to really throw you. And in your assignment, you might have arrays of structs as well. But just so that you remember that structs are really just another variable. So you can have an array of any other variable, really. And you can have an array of arrays. So exciting. So you can pop more arrays into arrays. And what that means, what does an array of arrays look like? So think of it as a bit of a grid, okay? And it means that you can access an element that you need by specifying a grid. So for example, you have your rows, they always run, obviously they run down because a row is across, and the columns are labeled across because they run down. Which makes zero sense and is not very, I always have to, like, I really have big issues with rows and columns for some reason, but I always have to kind of just be like, okay, a row is across, a column is down. So that means the columns are running at the top of my grid two-dimensional array, and the rows are running down the vertical side of it. So what we have is when we want to access an array of arrays, and let's say we use the parcels example from last week. So let's say when we use the one-dimensional array, what I was doing is collecting the parcels over 7 days, so that's 1 week. But what happens if I want to do it over a month? Okay, then I would have, what would happen is I would have 4 rows, right? So each one of these is, say, 1 more week, and then each one of these is the 7 days in that week. So what we get is that there is, first is the row, so 4 rows in this array of arrays, and there are 7 columns in this array of arrays. So always you refer to it as the name of the array, and then you say the row and then the column. In this case, this one is just filled with random numbers, but then you can refer to any part of this array. So in the same way that we ask for an element of a one-dimensional array by specifying the column, I would specify the row and the column, and it would give me, so for example, parcels 4, 7, okay, is going to have, what's it going to have? It's going to have nothing in it because there is no such index as index 4 because our indexing starts at 0, okay? So this is just the size of the array. And it's pretty important to have the size of the array specified up front, again, because it lets C know how much memory to store up for it. and it allows C to know where to place this array as well. So for example, if I wanted the number 13, I would refer to it as row 1, column 2. So I would say parcels 1, 2, and that will give me the number 13. Okay. If say I need 25 over here, again, I'm in row 2, column 4. So that means I would say parcels 2, and then the second lot of square brackets will have a 4. So parcels 2, 4 is what's going to give me this element 25 that I want to access. So think of it as a grid. And in your assignment, you have this piece of farmland that is already, you're given the size of it, right? And what happens is that it's basically a 2-dimensional array that you're going to be playing around with. So in the assignment, you're going to be playing around with these 2-dimensional arrays a lot. And hopefully that means you'll get quite confident using them. So how would we go through this 2-dimensional array? It's, we've learned how to go through 1 dimension of array. We just traverse through with a while loop. Now, if you think back to week 2, in the problem where we printed a grid of stars or a grid, we printed a grid of numbers when we went 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If you remember how we did that, we initialized our row, and then we went, row was on top, and then columns was inside. And that is exactly how we print. This is exactly how we print our lovely 2-dimensional array. So if you notice here, it's really the same piece of code as when we were just printing a grid that translates to a 2-dimensional array. So your columns are sitting on the inside, and the columns is what's going to keep repeating. Because the columns were up the top and they were going 0, 1, 2, 3, 4, 5, 6, 7, we need to return the columns back to the start each time we increase the row. Whatever we need to do many times and then go back to the start, that's the one that's going to sit inside, inside the first while loop. So the columns are on the inside because that's the one that's going to keep repeating each time. And then I have the initialization of column back to 0 every time that our row increases. So the columns is going to get set back to 0, and then it's going to go through again, and it's going to print it out again. So let's see it in action just by doing a simple printout of a 2-dimensional array, just so that you kind of get familiar a little bit with the code and also how to initialize and how to declare a 2-dimensional array as well. So I'm just going to change screens again, and sorry, for some reason, Teams also doesn't like me. Basically, no technology likes me today. So hopefully it doesn't take too long to change over. No cameos this time. Everyone's hidden themselves behind switched off cameras. Okay, here we go.
We need like intermission music.
I know, I really do. It's so awkward. I'm sorry. It's just this awkward bunch of silence.
I'm happy to get some
Tom,
ready
sing.
if you'd like.
I thought you were just going to sing for us.
Tempted as that may be, maybe not.
Okay, here we go. Look at this. We've got a piece of code. How exciting. Okay, so let's go to this print 2D array. Okay, so remember that 2D arrays are initialized with our size. We access the row first, then the column, and that means that the column
sharing,
is.
by the way.
Oh, it's not sharing. It's just looking at me in a very huge format. Apologies, everyone. This technology today, it's never been this bad.
I think everyone's just having a hard day after, long weekend. Fair enough.
All right, here we go. We're back. I'm sorry. Yep. Okay, let's try it again. Okay. so we've got our array row column. So this means that the column is on the inner loop. And if you look, it happens, it's the second thing that we call. So it kind of makes sense that it's on the inner loop and row is on the outside. So it kind of maps directly to where it is physically placed as well. And Tom, your microphone is on, so we can hear you typing. What a mess. I've just got like 7 days worth of Monday morning vibes. Okay, and the daylight savings as well, the fact that it's really an hour earlier, it's just not happening today. Okay, so we've got our array row column for a 2-dimensional array. The column is on the inside of the loop, the row is on the outside of the loop. So if you remember, we used a clock analogy. So it's like the column is the second, it has to tick over 60 times before the row ticks over one and another one ticks over. Basically, it's all moving around like that. Beautiful. So now we want to print out a 2D array of numbers, okay? So let's declare the 2D array and initialize it with numbers, and then we can print it out. And this way you get to see how the 2D array works as well in the many different ways that we do it. So what I want to do is let's do a shortish array so that we can see where it's going. And what I'll quickly do is I'm just going to draw up for you. So let's say I want to have this array, and I'm going to say it's going to be, I don't know, 3 rows and 4 columns. Okay, what that means is I'm going to have my rows here, and the rows are going to be 0, 1, 2. Because there's 3 rows, remember indexing starts at 0, so 0, 1, 2 actually gives me 3 rows. And my columns will run across. And again, if there's 4 columns, the indexing is going to go 0, 1, 2, 3. And what it will give me is it will give me this array that looks exactly like a grid. So inside here, I want to put some sort of values, okay, initially, because that will allow me to actually play around with what's going on. So if we are to declare this array, this lovely array of, okay, let's, the array again is of type int because I'm going to store ints in it. It can be of type double as well if we want, but I'm just going to do it as an int. And Neil's asked if we can do a printing in a separate function. We absolutely can. And the next piece of code actually has it as a separate function that I already give to you because we've just done it now. So I'm going to call it array because I'm creative like that. And I said that I would do an array with 3 rows and I'm going to do 4 columns. So now I've given my array a size. Now remember, these two over here, they don't actually change, do they? They are always exactly the same. I can't change. Once I start running my program, I can't change the size of it. So they're very good contenders to have as hash defines. So for example, I can say number of rows is going to be 3, and I can hash define the number of columns as 4. And the reason I do that is because they're not going to change all through at any stage throughout the code. And then instead of having it 3 and a 4, I can have number of rows and number of columns. Now, this is also helpful to remind you which one comes first, that rows comes first, columns come second. So you kind of have it explicitly written now instead of having a 3 and a 4, which, if you go back in a week or two, maybe you'll have another brain fart like me and be like, oh, which way is row, which way is column? What is a row? What is a column? What is my English? So in this way, if you go back in a month's time, it's still there for you, which way is the row and which way is the column. Okay, and then to initialize it, so we've seen that we initialize a 1-dimensional array. So we've seen when we do if we had a 1 dimension here, so let's say we had something with 3, we put a curly bracket, and then we have, I don't know, 1, 2, 3. So this is quite similar, except now you have dimensions to it. So the way that you can do it is that each one can have, so let's say I have 1, 2, 3. This is my problem with rows and columns again. Just wait, just wait. So if I have how many rows? If I have 3 rows, what that means is I'll have three lots of arrays, okay? 3 lots of one-dimensional arrays inside arrays. So then I have 4 numbers in each here. So 1, 2, 3, 4. What should I have the numbers here? 5, 6, 7, 8. It must be fun watching me struggle with rows and columns each time. I don't know why that is a thing for me. Rows left and right also is a weird thing for me. Okay, so I have this lovely array here now that I've initialized to have 3 rows and 4 columns. So here I have 3 rows. So 1, 2, 3 rows. And then I have the columns. So what that looks like and what that should look like is I have 3 rows, and that means my rows are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is what my array of arrays is going to look like, in that I have 3 rows and each row has 4 columns. So altogether, it's going to look like this type of 2-dimensional grid. Okay, so in that case, then what we have is we have this lovely array now that we can play with, and we want to be able to type a few things out. So let's say we, again, remember rows comes first. So I'm going to initialize my row to 0, and I'm going to open my row loop. So whilst my row is less than the number of rows that I have, and what this means now is I also don't have random numbers in my code. Instead, I'm using an actual term for it. And let's not forget to also increment. So row plus plus here. And then in here, I want to be able to open my columns as well. So exactly the same as when we printed out the grid, I want to do it in exactly the same way. So here I've gone through my different, this allows me to go through the different rows. So if I'm standing here at 1, then I will go down to 5, down to 9. But now I need to be able to go through this column. So I need to be able to go through all the columns, which means that I have to start my inner loop. So I'll have an int column, and I'm going to initialize it to 0 as well, and open a loop for my columns. So while column is less than number of columns. And again, in here, I'm going to do a lovely increment of columns. And what I said I wanted to do is I'm going to print out my array. So I'm going to print out whatever the number is in the array, and I'm going to do a little space after it so it doesn't look horrific. And I want to print out whatever is sitting in the array, and I want to print out whatever is sitting in the index of row and in the index of column. So remember, this way I get one single element printed out here. Okay, and then what do I have to do? After I finish printing out all of my columns here, so after I finish printing out this one row, and before I move on to the next row, I want to be able to print out a new line so that it switches me over to the new line when I need to go and print it out again. So I'm going to print out a random new line. Well, it's not random, it's there for a reason, but I'm going to print out this new line, increase my rows, and then I've finished. So let's see what it does when we actually want to print the array. So let's try, and I'll clear this. And I've forgotten what the program is called, print2darray.c. Okay, let me compile it now. Okay, forgot a semicolon somewhere at the very beginning. Let's try that again. Okay, so we compile. Okay, so now I'm going to run it, and we'll see what gets printed out. And what gets printed out is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it just doesn't look that nice because I've got double-digit numbers. But what happens is that it prints it out in that sort of grid pattern. So it helps you to envisage what that 2D array actually looks like as well. So that is a very simple way to be able to print out this two-dimensional array. And you guys will become very familiar with this type of code, because that is also the way that you traverse through a two-dimensional array, in that you are, you open up your while inside a while, and you traverse through the columns, and then you increase the row, and then you go through the columns again, and then you increase the row, and then so on and so forth. So you are basically, moving through it and checking each element in a grid. And we actually give you some type of starter code, and part of that starter code prints out this two-dimensional array for you. So you guys in the assignment are going to get this farm squares, and we've actually done that for you. So that's quite exciting. So Kiana, what did you say? Is there a way to make it a grid pattern? Print a space, for example, instead of 1, or the tens place. Yeah, you can do all sorts of things. Absolutely, you can do all sorts of things. I can print whatever I want there, and I can change it in any way that I want. So what I was trying to print out is exactly what is stored in that array, to show you the kind of the cross between having that array the way you visualized it, but also having what are the numbers in that array as well. So that was a simple way to print out that grid. And now I wanted to do something a little bit more intense, in that I want to do something that is more similar to the assignment and how the assignment starts. So I'm going to do a problem that is a little bit more similar to that. And we still have 16 minutes to go. So hopefully I'll be able to finish it if we do a kind of a simple version, or if you have any other questions. Okay, my problem is Jax and Juno go on a nighttime walk. Jax and Juno are 2 adventurous dogs who love to do nighttime park exploring with Sasha. And this program will show their efforts exploring one particular park, which is size 10 by 10. I'm going to start only with Jax exploring because Juno has gone into a big puddle and now she's too disgusting and covered in blue algae to move. So in the assignment and in here, what I've done is I've given you some starter code. So let's have a look at what it looks like to have starter code as well. And this is what you're going to get for your assignment. So when you copy over the initial file of your assignment, you're going to get something that kind of looks like this, but a lot more, there's going to be a lot more to it, because obviously the assignment is a lot bigger than one small problem that we're about to solve. So in this starter code, what you're given is you're given your hash defines, and what it means is that I've defined how big my two-dimensional array is going to be. So the park, or whatever that grid is, it's going to be a 10 by 10. What I've also done is I've created a struct for my dog, and I'm going to have a char name in that struct. I'm going to have a position in a row and a position in the column. So each dog, or let's just do Jax for now, Jax is going to have a character for his name, and he's going to have his position also related to him in this structure. So I've created a structure to house all of these related components together, because they all kind of belong to Jax. I've also given a helper function which prints out the park map as a two-dimensional grid. So if you have a look, the function is of type void because it doesn't return anything, it just prints out. It's called print park, this function. And what this function is given is it's given the two-dimensional array of the park. So it's given the two-dimensional array park with a number of rows and number of columns. And it's important to specify the size of that two-dimensional array when you pass it on to a function, which is what we've done here. And also what I've given it is I've given it this struct dog Jax, okay? So I've given it some sort of variable called Jax of type struct dog. And what that means is that it is able to place Jax on this map. So the reason I gave those two things as inputs to this function is so that you can print out this array, this two-dimensional array, but also so that you know in that two-dimensional array where this structure, where this dog is sitting in that grid. In the main function, what you get is you get this in park n rows and columns. So you declared a two-dimensional array that is a park. And what I've done is I've also declared that I'm going to have a variable of type struct dog, and that variable is going to be called Jax. Now here it says Jax enters the park always from the bottom corner of the grid, and to do, initialize the coordinates of where Jax is standing when he enters the park. So what you're going to get in your assignment as well is you're going to get a lot of these types of little to-do things, and they're things where you need to maybe type in some code, or you need to change things, or you need to do stuff. And that will help you to actually go through and know what to do. So I'm going to run through this code to start with, and then we're going to draw a diagram, and then we're going to do the coding, because I think that helps you to solve the problem a little bit better, to visualize it a little bit more. Okay, then I'm calling the function print park, and I give it the array park, and I also give it this variable Jax, which, as we saw before, those are the two things I said I would give it. And that's the end of the main. In here, I have my helper function. This helper function prints the park as a two-dimensional array, and it also shows where the dog is maybe currently standing, although I haven't got that. It says here to do that. So my function print park is given the park as a two-dimensional array, and it's also given this structure of the dog of variable Jax, and exactly what we just did in the exercise beforehand. It initializes the row to 0. It moves through the rows using a while loop, initializes the column on the inside, and then it goes through the columns, and it basically prints out all the different, it prints out the array, the two-dimensional array. So if we were to run this code right now, this starter code, which I suggest that you get your starter code and you run it just to see what it does. So if I compile it and run it now, if only I can remember what on earth I've called that file. I should really do smaller names for my files. Okay, so you can see it compiles, and if I try running it just to see what I'm given, so to see where on earth I have to start, what it's done is it's just printed me a two-dimensional array that is 10 by 10 in size, okay? So that's all the starter code does, and then you have to do the rest. So let's have a look at what we have here. So let's go to the first thing here. It says initialize the coordinates of where Jax is standing in the park, and I am told that he enters from the bottom corner of the grid. So someone asked, why does the grid print 0, 0, 0, 0? Okay, the grid is printing 0, 0, 0 because I've initialized it all to be 0 here. So that means that the whole grid, all that this array has in it is this. It doesn't have any other numbers. 1, 2, 3, 4. This is all that this grid has in it. And so on and so forth for all of them, okay? So it's a 10 by 10 grid, but it's initialized all to 0. Now my indexes for this grid are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And same up here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I enter, okay, if I enter from the bottom corner of the grid, and I should have really said, so if I enter from this corner over here, what will be the index of this corner? So where do you think, what will be the coordinate of that corner? What will be the row and the column number if I enter in the bottom here? What do you reckon it will be? Row 9, column 0. Okay, you're entering over here if you're entering row 9, column 0, which is not incorrect because I gave a terrible description of where I want the dog to enter, but I wanted to enter over here, which is 9, 9. Yeah, so that's good. Excellent. So what I want to do is I want my dog to enter on the bottom corner. So I want it to enter at coordinate 9, 9. Oh no, I've got the spinning wheel of death. Don't die on me. Don't die. Yeah, that's what I thought. I thought you didn't see my circle. Okay. Spinning wheel of death, spinning wheel of death. What is happening? Just when you think you can't have any more tech issues today, just when you think you can't. Yeah. Please don't do this to me. I'm going to blame this one on VLab. You know, it looks so pretty as it sort of spins, but it's very deceiving spinning. Don't do it. Please don't do it. Okay, hang on. Give me a second. Sorry. VLab crashes for everyone. It's clearly, it's done with me today. In fact, my computer's done with me today. And I just, come on, just another 15 minutes, computer. You can do it. Okay. Just wheel of death everywhere. Wheel of death. I'm just not having a good day today with technology. I'm sorry, everyone. I don't know what is going on. Wake up. It's not even letting me force quit now. Oh my gosh. Mm-hmm. Yeah, okay. So what we're going to do is Tom is going to share his VLab and he's going to be my typing monkey. Thank you, Tom. Mm-hmm. Okay, here we go. We're about to go. We're about to go. Whilst my spinning wheel of death is happening, this lecture has been an experience for you all, I'm sure. But at least everyone's awake. It's kept everyone on their toes. Will she crash or will she not? When will it crash? jjparkadventure.c. Look at that. I'm my own directory on Tom's computer. Okay. Okay, fantastic. So we want to position our dog now. We want to position him at 9, 9. Okay. So if we look inside the struct of dog, you can see that the names for those variables are called int position col and int position row. And my variable name for the struct is called Jax. So if you remember for the structs, I'm going to have then the variable name is Jax. So to access that struct down the bottom, I've done the first one for you. Jax.name is equal to a capital J. Okay, so I've given a char to the dog name. And now to give the dog a position, I'm going to say Jax.position row is equal to 9. And it's always easier, you know, when we're styling as well and when we're putting in our things, I'm going to keep the row on top of the column because that's how I refer to them everywhere else. So that means I'll never have to try and visualize something different in my head. And then I'm going to do the Jack's dot position col, and that's also going to be equal to 9. So what that does is inside that struct, it positions a variable of name Jax, and in that struct, Jax as a variable has a letter J, that is its char name. It also has a 9 as its position row, and it has a 9 as its position column. So what that's done now is it's positioned the dog. So how about we now go and try and print this dog out? So if we go down to our print function, so go down to our print function where it is. Yep, beautiful. So now we have another to do in the print function. So far, all we're doing is we're printing out the actual park. So we're printing out just the two-dimensional array. But now we want to print out where Jax is standing. We want to print out a big J there. Okay. So in that case, what we need to do is we need to check where Jax is standing. So if Jax's position is equal to the current position where we are in of printing out this array, and I wish I could draw it for you, but I'm too frozen to draw it. Tom, are you able to draw things on your Yep. So if we have this beautiful 10 by 10 array, if you can draw a draft array for us, just a 10 by 10, please. Okay, make it, well, you don't have to fill it all in, but just if you can just do a 10 by 10, just so that we can visualize it straight up. And we can also test your drawing skills at the same time. Fantastic. Those are beautiful lines. So this lecture will be recorded. For those that need to leave, I absolutely understand. We might finish it up after we put the J on, and I will pick up tomorrow where we left off. Sorry, Tom. Maybe we should have got done smaller. It's like I'm really slowly torturing Tom here. Beautiful. Okay. Let's pretend that those squares are all even as well, because each element is exactly the same size. Okay. Jax is standing at the coordinate 9, 9. So can you please draw a J for us where Jax is standing? Oh, how fantastic. There we have our beautiful J, which is standing. So if you understand, when we're printing out our loop, okay, it's printing out zeros. In a different color, Tom, could you please write in a few zeros to show us what's going on where we're, did you know? Kiana's just pointed out that you drew a 9 by 10.
I'd just like to formally apologize to everyone in the lecture for my counting skills. This is why I leave it to computers to do.
Okay, so when we're printing out all of those zeros, okay, when we get to the position that is 9, 9, we actually want to print out a J. We don't want to print out a 0. So we want to check where we're at. If we are at the position of 9, 9, then we want to print out a J instead of a 0. Okay, so let's try. How do you reckon we would do that? How would we check? if we're at position 99, then we want to print out a J and not a 0 as we normally would. So how would we check if we're at position 99? What do you guys reckon? Yeah, an if statement sounds great. Let's do it. Let's check if we are at position 99. So inside our while loop, when we're inside our while columns, we're going to check if we're at position 99. But Jax's position might actually change. We don't know that. We want to be able to print it as it goes. So how do we access where he is right now? And Lisa's got it. So we Jax.position row, if it's equal to the current row where we are at, yeah, then we're going to, and if the row and the column are equal to the current position where we're at in our printing, then we want to print out a Jax. So if our Jax.position row is equal to row and our position column is equal to column, so if Jax position column is equal to column, then we want to print out the character, so a %C. Tom, you there or are you dying as well now? Okay. Yeah, and then we have a Jax. And remember, if we access the member of the struct called name, that will give us whatever the character is that we have in the name. So Jax.name will give us what that character is. Okay, so now let's try to compile it and run it, and we'll see what it does and whether it works for us. Yes, you have.
I've made a mistake here, just so everyone can hear me.
Yeah, Tom has made a mistake because this is probably some sort of form of torture. We'll see if anyone can find this mistake. Do you want to compile for us?
Phew. Alrighty, so that's compiled.
Yep.
Shall we run it now?
Yep.
Interesting.
That is very interesting indeed. Can you run it for me?
I've run it. I think you're seeing a bit behind what I'm seeing.
Oh.
That's the problem here. So yes, just assume that I've done what you wanted.
Look at what it has done. How bizarre. Oh yeah, I think Christian is right. It was agreeing to be my typing. Okay, so what? Yes, okay, excellent. So someone has picked the mistake, printed both J and 0 instead of either. Yep. Okay, very good. So, and I think Lisa has also have an else statement for the other printf. Yes. Yeah. Global warming, that's a good one. All right, can we go back to the gedit and can we modify that to now have not just an if statement, but also an else. So else print that beautiful printf and the %D.
Done.
Thank you so much. And now let's try running it again and we'll see what it does.
Alrighty, so I'm going to use the up arrow to compile it again. And then I'm going to run /JJParkAdventure. Ooh, maybe it didn't work. I've made another mistake here, which I'm pretty sure hopefully people will notice. There's that little asterisk in the top left. So let's fix that. Remember to save your file before you compile it. I'll recompile, and then I'll / again. And now the J is in the right place.
Amazing. Now we've got a beautiful printout of a park and the location of Jax, and he is ready to go on his adventure. Unfortunately, we have run out of time today. So his adventure is going to have to wait for tomorrow. So tomorrow we're going to continue on here, and then we're going to learn about something new as well. So that's going to be exciting. Hopefully the tech issues will not come back tomorrow to haunt us. I'm so sorry about today. I hope that you still got something out of the lecture. Apologies for all the technical issues. You got to watch Tom type super fast, so that was probably really exciting. And we look forward to seeing you tomorrow when we do a little bit more of this, and then we do a little bit more of other things as well. All right, guys, thanks so much for tuning in today, and we will see you tomorrow for another exciting adventure.
Thanks very much, everyone.